My apologies for the previous video getting cut off. I'm still getting the hang of this, obviously. What we were doing at the very end of the last video was checking to see that if we are approaching, 9 from the right, 9.1, 9.01, 9.001, that we also have our f(x) values get close to 6. And so we can see, let me just copy down some numbers, that we can see that, yes, they very much are getting closer to 6. So again, this gives us both graphical and numerical confirmation that the limit of this is equal to 6. We will leave actually evaluating this for real for a future section, section 2.5. Textbook also has a quick example. Just note here, f of x is equal to 1 plus x raised to the 1 over x power. And so the question is, what happens as x gets close to 0? 1 plus x to the 1 over x power. And so if you do this with graphically, if you do this with a, or if you do this numerically or something like that. So let's realize as x gets close to 0, we have something that looks like 1 to the 1 over 0 power, and that's a really weird thing to do. So, so this is something we'll consider in the future. It's just not something we can just plug in x equal to 0 and so we know the answer. But from this graph, we can see it looks like it is, the limit is defined. And if I give you some information about the x-axis, you can see it's a little bit between, sorry, not the x-axis, the y-axis, you can see it's between 2 and 3. And in fact, if we made a chart like we did before, it's going to be around 2.718. And that number is, I don't know if you recognize this or not, but that is going to be e. So e is the base of e to the x. It's the base of the natural log. That's something that we will investigate certainly more in the future. So far in this example session, we've done lots of positive examples. It's worth for us to also do one negative example, a function that does not have a limit. So if we were to take f of x is equal to sine of pi over x, and so we ask what is the limit as x goes to 0 of sine of pi over x. So realize that this is a pretty weird thing, that as x is closer to 0, we'd be divided by 0. So once again, that we can't just plug in 0 here. And if we try to sketch it, some really weird stuff happens. So let me put on here 1 and minus 1. So something that's going to be true is that all of our sine of x, or sine of whatever, is always bounded between 1 and minus 1. So this function, sine of pi over x, is always going to stay between 1 and minus 1. But some kind of weird behavior is going to happen. But let me draw what happens. So here, let's say this is 1. So when x is 1, sine of pi over, so this is sine of pi over 1, and that's going to equal 0. And so what happens is that you have, like, this picture goes on, and it bottoms out at 0, and then it comes back and goes through where this is 1/2, and then it goes all the way up and hits 1 again, and then comes back through at 1/3, and comes back through at 1/4, and it just starts oscillating like crazy up and down, and to the point at which the picture basically looks like this. Obviously, it's a function, so it has to satisfy the vertical line test. This doesn't do it, but it's to illustrate that we have a really messy picture going on here. Something similar happens on the other side. Oscillates up and down like crazy, and at some point the picture just basically looks like that. If you don't like my drawing, let me just move the textbook here in front of you. You can see that what's happening there is just oscillating infinitely up and down, up and down, up and down as you approaching zero from either the left or the right. And so the textbook basically just showing this as a pink rectangle here. So this is very suggestive that this limit does not exist, and that's the case, that there is no value that f of x approaches as x is close to 0, because it just keeps oscillating back between 1 and minus 1, 1 and minus 1, 1 and minus 1. There's no way to get it to zoom in on any single output value. You could also do this by a little table of values. Just as a sample here, x and sine of pi over x. So if x is 0.1, sine of pi over x is 0. If x is 0.03, the output is minus 0.866 ... 0.007, 0.434 ... 0.00, 3 zeros and a 9, minus 0.342 ... So we can see here these are getting very close to 0, and sine of pi over x has no intention of settling down all 0, something negative, something positive, something negative. Just to show one more, 0.00065, 0.935, something very positive, no intention of settling down. So here's an example where both from graphically and from the data, we can see that the limit here does not exist. So in this video, we saw some more examples of showing that limits do exist and don't exist from this numerical and graphical standpoint.